In this video, I'm going to do the proof of law of sines. And you see here I have triangle ABC, and I'm going to take this non-right triangle, and I'm going to drop an altitude from point A to segment BC, or little a, which is 90 degrees. Thereby creating a triangle from B to here to A, that's 90, and also over here. I can use then law of sines, or not law of sines, I can use sine, cosine, tangent. I can write sine of B equals the height of the altitude of this triangle h over c, and I can use sine of c equals h over b. Once I have set these two things, the only thing common in these two equations is h. So I'm going to set h equal to h. I'm going to do that by first solving each of these two equations for h by multiplying each side by the denominator, and gives me the following below. Moving to the next step then, I can set h equal to h, or cb sine equals bc sine. Well, what if I divide both sides by BC, that length? Neither of those will be zero, so they're both non-zeros. Well, if I do that, and I divide both sides by CB, what you're going to see happen here is that the angle and the opposite leg are both on each side of the equation. Here's sine B over little b, and then likewise on the other side, here's this angle C, and here's little c opposite, and that's this side. That is basically what law of sines is saying. And once you set, those two will be equal to each other because of the altitude h they use. Likewise, if I was to draw this triangle and draw the altitude from B, I could create the same proof, proving sine A over A equals sine C over C. And then likewise would equal sine B. And thus we have the law of sines. So pulling this to a new page, we have sine A over A equals sine B over B equals sine C over C for a triangle of ABC. Well, my first triangle example was for triangle EPR. Well, that would simply change this A to an E, this B to a P, and this C to an R. If we draw this, and it does not matter if it's scaled or not, we now have triangle EPR, where they called out the angle 47. They called out angle R as the unknown. They called out little r is 9 and little e is 13. Well, using this law of sines, we can quickly write the following proportion with two ratios by using 47 and the 13, the angle and the leg opposite for one of the two ratios, and then 9 and the unknown here. So again, sine 47 over 13 is the one ratio. The second ratio here will be the two parallelograms, the 9 and the r, which is sine r. And again, my first step here will be to cross multiply these two. Sine r times 13 equals 9 sine 47. And now this becomes an exercise in solving an equation, which I've shown in these steps. So if we pick up from this step, I gotta get sine r by itself, so I'll divide both sides by 13. I get sine r, which is one thing, equals this, 9 sine 47 over 13. Dividing it out, I get 0.5603. Since sine is always a ratio of the opposite leg over the hypotenuse, it always has to be between 0 and 1. Well, sine r then equals 0.5603. Well, again, oh calculator of mine, I know the ratio. Please, oh please, tell me the angle. And if you take sine negative 1, 0.5603, you get something north of 30 degrees. 30 degrees was my estimate, which I wrote in. And if I take my calculator and check it, I get approximately 34 degrees as the final answer, rounded. And that is angle R. Now, we're going to try another example here, working from the top down. So we'll go to the new page here. Again, for triangle EPR, they show the angle of P is 62, the angle of E is 26, and they give you R is 2.6, and they want you to find P. Again, there's the law of sines from our proof. Again, I'll do a quick and very rough sketch of triangle EPR. EPR does not matter, that's not the scale. Angle E is 26 degrees, so I'll put that in. Angle P is 62 degrees. Little r is 2.6. And they want us to find little p, which I'll mark as little p across from p. Well, we know we want to use the angle on the leg, so I'm going to use the 62 and the p. Well, the only other leg I know is 2.6. But from the initial information, I don't know r. But since I know angle, we know angle equals angle. So we can take 180 minus 62 minus 26, and I'm going to get that angle R is 92 degrees. So we're going to pull all this green stuff out, and we know that angle R then is 92 degrees. That allows us to set up our ratio. And again, we're going to use leg angle P and leg P, and angle R and leg R. So our ratio is sine of 62 degrees, which is P, angle P, law of sines, over P, equals, the other ratio is sine of 92 degrees over 2.6. Now, what confuses students a lot of times is how do you get an angle greater than 90 degrees in your calculator? It works in the idea that it rotates beyond 90, and there is trig for this in the obtuse triangle for dropping the hypotenuse. Or for a height, I mean, an altitude. So we can do this. So we multiply across. We get 2.6 sine 62 equals T sine 92. Well, to get P alone, all I got to do is divide both sides by sine 92. And I'll just cross it off on the right side. And I got 2.6 sine 62 over sine 92. If we use our calculator, I get 2.3 equals P. And we have just found P. Law of sines, again, sine A over A equals sine B over B equals sine C over C for any triangle is a shortcut for dropping altitudes.